Hello everyone and welcome to the Calculus and Complex Number tutorials. In this tutorial, we will learn how to compute a reciprocal of a complex number. This problem is very important for electrical and mechanical engineering students studying signals and systems as well as control theory. Here's the problem that we want to solve. Consider this expression, where I is the imaginary unit. The number in the denominator of this expression is a complex number. We want to provide the answer to the following question and solve the following problem. First of all, is this expression q a complex number? Secondly, if yes, write this complex number in the standard or rectangular form given by the equation number 2, where a is the real part of q and b is the imaginary part of q. Before I start with explanations, I need to mention the following. It took me a significant amount of time, energy, and planning to create this video tutorial, as well as more than 400 video tutorials that you can find on my YouTube channel, and consequently I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start. The answer to the first question is yes. This is indeed a complex number, and the reasons why will become clear by the end of this video tutorial. Generally speaking, a reciprocal of a complex number is a complex number. To solve this problem, we need to somehow transform this expression into a form in which the denominator is a real number. To do that, we need to use one very simple but elegant idea. Namely, let z be a complex number. I will denote the real part of z by w and the imaginary part of z by g, and I will here have imaginary unit. W and g can be arbitrary numbers. Then, let us multiply z by its complex conjugate. That is, we want to compute this. W plus gi multiplied by w minus gi. This is equal to w times w is w squared. Then w multiplying gi with the minus sign is minus wgi. Then gi multiplying w is plus wgi. Then gi multiplying gi is gi squared. However, we have a minus sign over here. So we can write minus gi squared. Perfect. Now, obviously, these two terms cancel each other, and the result is given over here. W squared minus gi squared. This expression over here can be written like this. W squared plus g squared. This is because I squared is equal to minus 1. And if we multiply minus 1 by this minus, we obtain plus over here. And that's it. So why this simple example is important? Well, if we take a complex number and if we multiply this complex number by complex conjugate of that number, we obtain a real number. Also, another thing should be observed over here. Namely, this expression over here is very similar to the very well-known expression for the difference of squares of the two real numbers. Namely, from basic calculus, we know that S1 minus S2 multiplying S1 plus S2 is actually equal to S1 squared minus S2 squared. Now compare this formula with this expression over here. They are very similar to each other. Now let us use this simple trick to solve our problem. We can write Q is equal to 1 over 3 plus 2i. The idea over here is to create a real number in the denominator. To do that, we will multiply the numerator and the denominator with the identical number, and that identical number will be the conjugate complex number or complex conjugate of the number in the denominator. That is, we'll multiply both the numerator and the denominator with 3 minus 2i and 3 minus 2i. Next, we have, in the denominator, we have 3 squared minus 2i squared. I'm simply using this formula over here. And in the numerator, we have 3 minus 2i. Then, this simplifies and we obtain 9. Over here we have minus, and over here we have minus 4. In the numerator we have 3 minus 2i. This is equal to 3 minus 2i divided by 9 plus 4 is 13. And consequently, q can be written as 3 over 13 minus 2 over 13 multiplying I. And that's it. The real part of Q is 3 over 13, and the imaginary part of Q is minus 2 over 13. Consequently, we conclude that Q is actually a complex number with the real and imaginary parts given over here. And this solves our problem. Here's a bonus. Here's another important thing that I will teach you. I will teach you how to verify these computations in Python. There are two approaches. The first approach is to use built-in Python complex variables and corresponding functions. We define complex numbers in Python like this. For example, if I want to define a complex number that looks like this, 2 plus 5i, I will type this complex number in Python like this. Over here, I will type 2 plus 5j, and I will denote it by, for example, d1. Okay, now if I type d1 over here, I will see that it is actually a complex number. Here, you need to observe that Python uses j instead of I as an imaginary unit. So always keep in mind that. Okay, so to solve our problem, we will first define the expression in the denominator. The expression is 3 plus 2i, or in the Python's notation, 3 plus 2j, and here it is. Here is the expression. We obtain float numbers. We don't obtain nice fractions. However, we can verify that this expression is actually correct by simply dividing 3 over 13. That's the real part of the solution. And we can see that it's exactly this number over here. And if we divide 2 over 13 with a minus sign, this should give us the imaginary part, and we can see that this imaginary part is actually equal to this expression. Okay, that was the first approach. Let's explain the second approach. In the second approach, we will be using the Python symbolic library. The name of this library is SymPy. First, I will import all the functions and packages from SymPy, and I will call this function initPrinting for nicely printing the expressions. Then, over here, I will define the number in the denominator. Note over here that SymPy library uses capital I to denote imaginary units. Consequently, I will need to type 3 plus I times 2. and this is z1. Okay, and then finally I will say r2 is 1 over z1, and this is the solution. Let's see r2. Here it is. If we want to extract the real and imaginary parts, that is, if we want to separate them, we will simply type this. Simplify r2, and we will assign the result to r3. And here it is. And that's it. Okay, that would be all for today. I hope that you like the videos I'm creating. Please press the like and subscribe buttons. Thanks a lot and have a nice day.